Hello, everybody. I hope you can see my screen and everybody can hear me. So welcome to today's webinar. The topic of today, as you can see, is communications for automated monitoring. And before we start, my name is Christian Adenschein. I'm product manager for different monitoring products. I'm based out of Munich in Germany and have been with Trimble since 2011. Today, my co-presenter is David Ward. David is a very experienced colleague, and I'm very happy that he shares some of his knowledge today during this webinar. David, do you want to introduce yourself?
Sure. Hello, I'm David Ward. I'm a technical support engineer with the Trimble Advanced Positioning Support Team. I've been with Trimble since 2008, and I'm based in the US. I have over 30 years experience working with installing and repairing radio and network communication systems. And I'm licensed by the US Federal Communications Commission with both commercial and amateur radio licenses.
Great, thanks, David. Let's have a look at our agenda for today. So I will start with an introduction before David runs us through a couple of communication scenarios. And towards the end, I will point you to some resources that are available around Trimble monitoring. And I will also give you an outlook on the next webinars, on the next Power Hour sessions that will come up soon. And of course, we will also at the end, we will still have time for questions and answers. But it doesn't mean that we need to wait until the end of the Power Hour of the webinar until we can discuss or answer some of the questions. So if you have any questions during the webinar, please just type them in the chat window, and we will address them as we go. If we don't get to your question during today's webinar, we will try to follow up afterwards. But ideally, we can answer all of your questions while we go. Okay, so communication. Communication is really it's a critical element of monitoring. This is because, I mean, the main purpose of an automated monitoring system is real-time alarming. In case something moves, you just want to get informed. It's not just movement, it can also be something accelerates, or let's say generally speaking, if a certain value exceeds a predefined threshold. So this is what you're looking for when you install and set up an automated monitoring system, right? So what is communication? Communication is the act of transferring information from one place to another. Communication involves at least one sender, a message, and a recipient. So if you now think about monitoring, a sender can be seen as a sensor, and the message that is actually transferred is the sensor data, and the recipient is our monitoring software, Trimble 4D Control. So now if you look at that image here, the sensor in this case is the total station that sends data over to T4D, Trimble 4D Control. Data is basically the observations that the total station takes. And the communication in this example is established by the help of a USB cable. So looking at this picture, you might wonder, okay, what is the challenge here and why is it actually worth to talk about it, right? The reason is quite simple. So what you see here is really by far not representing reality. So in reality, the communication between a sensor in the field and the software that is typically in the office and not next to your sensor, this can really be a challenge. And I would like to show you some examples of real monitoring installations. So monitoring sites can really be located in remote areas where you have not much communication infrastructure by default, and so this becomes quite obvious if you look at the images from our monitoring sites here. One is in Norway and the other one is in the US. One is about a GNSS receiver, and the other one, there you can see a total station and a weather station. But it really looks like it's in the middle of nowhere, right? And you can easily imagine there is no communication infrastructure available. But even in more urban areas, like here in this example from Italy, where you see a total station next to a rail station or a rail track, so even here, the communication part of a monitoring system is not as straightforward as it might look like. So, I mean, despite all of the possible challenges, we are still going to talk about, and David will run us, as I said, through a couple of scenarios. So, despite of all of those challenges, the communication can always be established in some way. So data is eventually flowing from the sensor into our software Trimble 4D control. And as you might already know, because you are already a user of Trimble 4D control, or because you attended previous monitoring webinars, T4D, again, our software solution for automated real-time monitoring, processes the data that are coming in. It does all the geodetic processing of total station data, of GNSS data, and it has a rich feature set for charting time series. You can create an analysis. It automatically creates reports, and it also triggers alarm notification if something happens on site. So this is Trimble 4D control in a nutshell, just in case you are not familiar with it. To summarize, we have all kind of applications out there. Like on this slide, you can see a building represents maybe can represent a construction site in some urban areas. Monitoring is also used on a dam, for example, or on a bridge. And yeah, with all these applications, we use different sensor types. The typical sensor types that are used are total stations, GNSS receiver, and geotechnical sensors. And all of the sensors are deployed on site in the field, whereas Trimble 4D control is typically installed in the office, right? So I mean, there are a lot of different types of communication, in fact, and types of communication, again, to transfer data from the sensors over to the office, to the software. And yeah, David is now going through a couple of scenarios and explains how we can best establish a communication for those. So this is the topic of today, connecting the field with the office. All right, let me check if there are any questions so far. How to set up T4D to receive SMS on a cell phone is one of the questions. So to receive SMS on a cell phone, so you can, this is basically not the communication between the sensors and the software, what is displayed here, but it's a good question. So you can define in Trimble 4D control, there is notification settings where you can select certain SMS providers which are available, and then you can specify to which user an alarm notification should be sent based on the cell phone number you have typed in once you created this account, right? I hope this answers your question. If not, maybe you can raise a follow-up question. Other than that, I cannot see any more questions so far. And yeah, with that, I will hand over to David. David, are you ready? Let me make you a presenter.
Okay. All right. Now, can you see my screen?
Yes.
Fantastic. So today, we're going to cover a series of somewhat representative communication scenarios, which we've seen in some installations. We won't be able to cover all the possibilities, but we hope that these will give you some ideas that you can use in your installations and let you know that you're not locked into one method of transferring the data from the monitoring location to the T4D control software. There are always complications of getting the data from the location where the monitoring is being done back to the T4D control server. And we hope that this presentation will give you some ideas to work with in getting through the complications. We will be discussing specifically total stations and GNSS receivers, but there are also possibilities here for the geotech sensors, weather station data, and any other remote data that you need to bring into T4D control. In our first scenario, we're going to talk about a building construction site where we've got a monitoring project going on. Excuse me. So the site is not large, and we have a total station monument that's near the location. This is our easiest scenario, right? The T4D control server and the total station are within Ethernet length of each other within 100 meters. So we don't have to put in any additional Ethernet repeaters or additional switches or equipment. We can just run a cable out to the total station through a conduit. In this case, because we're going to use straight Ethernet and the total station requires serial communications, we have to use a converter called the device server. This one is a Moxa 5200 N-type, and it just converts Ethernet to serial and serial to Ethernet. There are also device servers that connect Ethernet to USB. In this case, because we're using Ethernet, if we put a switch out or a router out by the total station, we can co-locate a GNSS receiver, in this case, the Trimble Alloy. And the Alloy, excuse me, would have its own IP address and could be addressable over the Ethernet. In our second scenario, we're going to talk about a bridge monitoring project. Imagine a bridge. We've got an office building when we can, like a construction trailer or something that's got a server sitting in it, and it can see the entirety of the bridge. So there's no barriers or obstructions in between, but it's too far for Ethernet. It's more than the 300 feet or 100 meters that is the maximum for Ethernet. So in this case, we can use a 2.4 gigahertz radio. The Trimble 2.4 gigahertz radio connects directly to the T4D control server. And it interfaces with and controls and communicates with robotic total stations. If you are using radios, one radio can control up to 5 total stations, and you can have more than one radio connected to the T4D control server software. If we need more range, you can put an external antenna on the radio by adding a coax and running it up, giving it more elevation. Our third scenario, we've got an earthen dam we're monitoring. Due to the location of the dam, there's no cellular connectivity, and the distances are much too far for Ethernet communications. This is way out in the middle of nowhere. There's no cellular. It's just totally isolated. So to complicate matters, we've also got hills in between where the T4D control server is located and the total station. So there's no direct visibility. But what we can do is use what is called an Ethernet or IP radio. This radio uses Ethernet protocols, and they can be connected into a network. When you have 2 or more, they effectively become an Ethernet range extender. Because we don't have direct line of sight communications, we can also add another radio configured as a repeater, and this would be able to relay the data between the 2 locations. These types of radios are configurable as point-to-point or point-to-multipoint, so that you can have multiple legs in the Ethernet radio network. And you can also use various external antenna types for better signal data transfer. Again, because we're using Ethernet protocol, it's very easy to plug a Trimble Alloy GNSS receiver in and have that data be used for monitoring as well. Are there any questions so far, Christian?
No, not really. No,
Okay.
no.
All right. So in this situation, we had a customer with a pit mine. It's a very rich gold mine, so they've got cellular towers out in this very remote area, which is uncommon. And they also have very good internet connectivity, so they can reach the web and communicate back with their head office. There are hills here, so the distance and visibility are a challenge to connect. What the customer ended up doing was they purchased a cellular modem that had serial adapter connectivity, so to be able to connect directly to the total station. And that way they could bring the data back through the cellular towers into the Trimble 4D control server. Again, because they chose which model cellular modem they had one that had Ethernet capability as well, and they decided to go ahead and put a GNSS monitoring site there as well.
Hey David,
Yes.
sorry for interrupting. So now we have just received a question. It is regarding the cellular modem. It's a question about security.
Okay.
How do we maintain security protocols? Can you elaborate on that one?
Sure.
I'm seeing your emails, David.
Huh?
I'm seeing your emails. You're off the wrong screen.
Yeah, I'm sorry.
I don't.
I somehow clicked the wrong button.
No worries.
So
it was about
security.
how do we maintain security protocols? That's the question, yes.
Right. So with cellular modems, some manufacturers have built-in protocols like VPN, virtual private network, that you can integrate with your existing system, with your existing network. And that would give you a private tunnel for the communications and likely prevent external intrusion into your network. I don't have a specific list of equipment because depending on the location and cellular providers, the exact security needs might be different. There are different regulations and different equipment standards and protocols, so I don't have any recommendations for specific equipment for different scenarios.
Okay. Yep. Thanks, David.
I hope that answers the question for everybody.
I hope so too. Otherwise, I will follow up on that one when I see something coming in. Thanks, David.
Okay. All right. Our next example is the same mine a few years later. They have the same situation. They've got Ethernet network protocol access, internet access. They still have the cellular towers, but they had a failure of one of the cellular tower, and they lost communications for over a month. So they had no data communications transferring into T4D, no monitoring happening at all. And so they came back and said, what can we do to maintain 100% data connectivity? So we recommended in this situation the set-top M1. The set-top M1 actually controls the total station and has a target file is loaded into it, and it runs the rounds and records the data into it, and then T4D control server reaches out to the set-top M1 and downloads that file for processing. So what happens if we have communications go down now? The set-top M1 is still running without any outside control from Trimble 4D control. It's still recording the rounds. And once communications comes back, once that cell tower comes back up, T4D control downloads the rounds files, and they can then be processed. So this gives us our, even if it's delayed, continuous processing of data. So our next scenario is a tunnel project. No radio communications are going to get into the tunnel. No visibility down the tunnel from the location where T4D control server is running. So what they did was they said, but we can put Ethernet down the tunnel, and we can probably put Ethernet amplifiers to extend the cable beyond the 100-meter maximum length down the cable. Because this is a very high-profile project, they wanted to maintain 100% reliability of the data. So they went with the set-top M1. But because they didn't have cellular connectivity, we used the set-top octohub to connect the set-top M1 to the Ethernet. So the set-top is still running the rounds itself, and T4D control is only downloading files. But if we lose connectivity, if the modem went down, or what, I mean, if the router went down or whatever, so we had no Ethernet into the tunnel, the set-top would still be recording the rounds. And
David,
yeah.
Here we just got another question. I think this was triggered when now that you're showing the OctoHub. It's about the configuration, I guess. The question is, does it require an IP address? So the combination between setup M1 and OctoHub. So I'm not sure if the question is clear, but so maybe you can just talk a little bit more about this, why you need the OctoHub and the connection, or the yeah.
So the OctoHub is the setup M1 does not have an Ethernet capable plug on it. So we have the OctoHub, which is an interface adapter that gives us the ability to connect several ways to it. And one of those methods, it's got an Ethernet connectivity to allow the set-top M1 to connect to an Ethernet network. The set-top gets programmed with the IP address, and the OctoHub does not require its own IP address. It is just a pass-through.
Mm-hmm. Okay, I think that answers the question.
Okay.
Thanks, David.
All right. So if the network fails, the set-top's recorded the rounds into a rounds file, and when the network comes back or is restored, T4D control can then download the rounds files for processing. Our next scenario, it was a landslide, and it was a very high-profile landslide. They had, well, this monitoring project's got to have 100% data. It's a government-funded project, and it's beneath the major coastal highway. So we have to maintain 100% of the data reliability. The total station's down below the cliff monitoring the fall area, and there's no cellular communications. There's also no visibility back to the T4D control server location. Of course, the distance is way too far again for Ethernet connectivity. So what we did was we used the Ethernet radios that we saw in a previous slide with the set-top M1 and the OctoHub. So we can maintain, again, 100% data connectivity because the set-top M1 is actually running the rounds and logging the data. And if the communications fails for any reason, if our repeater battery dies, solar power went down, whatever, we have 100% connectivity. When it comes back, the server downloads the files, and T4D processes the rounds data. Any questions so far?
Yeah, there's one question, but I think this goes back to the comment I already made on the SMS notifications. So,
okay.
So it's from Sasulan. I hope I pronounced it correctly. So can you throw off detailed instructions how to do it? So how to basically configure the SMS provider, and how to configure that someone receives an SMS if there is an alarm. So yeah, we can certainly provide you with detailed instructions maybe not during this webinar, but this is really straightforward in our T4D web application. So yeah, I can follow up on that, or our support team maybe after this webinar. So I guess this is nothing we can answer now.
I don't have a screen with T4D to log in
Yeah.
to show right now.
Yeah. Yeah, maybe you continue with scenario 7. Maybe we can discuss one.
Well, scenario 7 is just finishing, and
Okay.
I have
Okay.
I'm going to talk about. Oh, I somehow went too far. There we go. So we can look at networks and all the possible different combinations. We can do clusters or whatever. Look at the star scenario. Say we had a T4D server where this word star is, and the center or the hub would be a repeater, and it could communicate with multiple units in the multiple total stations. Or the same with the cluster. You can use multiple repeaters doing point to multi-point and have them talk back to the T4D server. So now we have talked about a bunch of possibilities where we have different network configurations. We have multiple total stations, multiple GNSS receivers. We can incorporate communications links that are wireline Ethernet, Ethernet radio, or have some of the links be cellular or network. Or we can also ensure data capture and storage in the event of communications outages with the setup M1. So by using a combination of radios and repeaters, wireline Ethernet and cellular, we can create data, transport the data, and process the data to monitor and analyze your project in the T4D control software. If there's no questions, then I'm going to go ahead and pass this back to Christian.
Actually, there is at least one I think is definitely you can comment on. So you were talking about yeah, IP radios, let's say. And so the question is, do you have a list of manufacturers for the IP radios?
Yeah, there are a lot of different manufacturers for IP radios that have a lot of different capabilities. Some of them have multiple Ethernet ports on them, 2 or 3 or 4. They can have 1 or 2 serial connectors on them. The thing is, because there are so many manufacturers and every country has their own radio communications regulations specifically, I don't keep a list of what radios are available for what country, right? So it'd be very difficult to keep a database of that type of thing. We can recommend them on a case-by-case basis if we are provided with communication standards of the country or whatever, you know. But we're always willing to assist the customers in trying to figure out their best network configuration.
Mm-hmm. Yeah, makes sense. All right, thanks, David. So there is actually a couple of more questions. One of them from Martin Gonzalez. Does setup can store temporarily GNSS data also, or only total station? So yeah, maybe I can just reply on that one. That's so the setup in one is made for the total station connection. So you can, as David just said, or said a couple of minutes ago, you can control the total station using the setup M1, and it can also buffer observations and yeah, so it's for the communication of a total station to Trimble 40 control. That is what a setup M1 is for, and so it's not about GNSS data.
No, the GNSS receivers store their own data in log files,
mm-hmm.
and T4D can download those using the storage integrity option for reliability, data reliability there.
Yeah, that's perfect that you mentioned this. So as you just said, David, maybe I don't know how many gigabytes you can actually store on the different variants of the NetR9 receiver. I think it's 2, 4, 8 gigabytes or something. And it's, as you say, you can still retrieve missing GNSS observations that way. And typically you would connect a GNSS receiver via Ethernet to Trimble 40 control. And the reason why I'm saying it's good that you mentioned it, because there is just another question I see from Fabien. This time it's about the setup M1, the storage capacity of the setup M1. So for instance, he writes, how long can we store with one total station and around 20 targets? So
yeah.
So the setup M1, maybe you know it better than I do, David, but it has a huge onboard storage. I think
1
it's
gigabyte.
at least 1 gigabyte. That's what I was about to say. Yes, and so 1 gigabyte of round information of total station measurements. So this is really a lot. So I do not expect that someone really hits this limit of 1 gigabyte. Otherwise, they're
Not with just 20 targets.
no.
It depends also on how often the rounds are taking place, right? But
Yeah,
even
but
so, that's a very small file with only 20 targets.
Exactly. So let's put it that way. So Fabien, if you reach that 1 gigabyte onboard storage of the setup M1, then we are dealing with other issues than buffering files on the setup M1, because that would mean you would like buffer 1 year of data or so. I cannot say it for sure, but a lot of data at least. So then
several months, right? I mean,
then it's not an automated real-time monitoring system anymore. So
no.
it's plenty of onboard memory, so you can buffer your data. That's for sure, right? Okay, what else do we have here? So Oluropo, again, I hope I pronounced that correctly. So there is the question for the dam monitoring project. If the location of the total station is too far from the T4D server and there is no internet connection in that area, how do we communicate with the server? So I guess when you say there is no internet connection, I guess you mean there is no cellular coverage, for example, and there is also no Ethernet connectivity. So that's what I understand from this question. And I guess then it's about then you can still establish a radio connection with maybe some repeater. But David, maybe that's something you can.
Oh yeah, yeah.
Can
So
add more.
you could even use multiple repeaters it tied together um, or linked over radio, so that they can hop the data back to the server if there's too much ground between the server location. And the main thing is to get the data back to an Ethernet port, right? So that we can get it into the internet. Once we've got it into the internet, we can get it to the server if the server's at a location where there's internet, right? So we can use various methods, but the 2 radios or 3 radios doing hops would definitely be able to do it.
Yeah. Okay. All right. And I see there's one more question from Alexander. What is the usual estimated cost per monitoring station or sensor?
Ooh.
Okay, so this is a difficult one to answer. First of all, I'm not quite sure if you are referring to the costs for connecting it to the software, in fact, or if you're referring to the costs for the physical device. But in any case, I mean the costs, it's not that one price. It really varies, right? So if we are talking about geotechnical sensors, so the price level is really low, let's say, compared to total stations and GNSS receivers, where it's a little bit higher, of course. But even with total stations and within GNSS receivers, there is a huge variety of different types of receivers and total stations. So this is why it's really hard to answer that question.
Right. And when you're talking about
Mhm.
a site, are you talking about the powering equipment
Exactly.
and the communications equipment and the monitoring equipment, the sensors and monitoring equipment? What monitoring equipment are you putting at the site? Is it a total station in conjunction with a weather station, or so a monitor site can be any number of things, and the prices can compound depending on how you configure it.
Exactly. So Alexander, I would recommend, if you're looking for a specific price information, regardless whether it's the actual sensor or if it's some software component or some communication piece, whatever, I would suggest maybe you reach out to your distribution partner, and so I'm sure they can provide all the information to you in more detail. Okay, so I'm looking again here. There is one question you can from Zasulan. You can do online learning. So yes, we can do that. I think Zasulan, you also raised the question about the notifications, SMS notifications. So I'll get back to you offline, right? I'll get back to you. And okay, so I think that's pretty much it for now, at least. Please raise more questions if you have some. I will just make me as a presenter again.
Yep.
Okay.
Are you a presenter? No.
No, I should be. Can you see my screen now, David?
Yes.
Okay, which one? Communication methods? Just to be
Yes.
sure. Yeah, okay,
Yes.
perfect. All right. So yeah, hang on, something is wrong here. Yeah, so the communication methods, this is more like a summary, this slide. The communication methods we have covered. So it includes Ethernet, radio, cellular, and as David illustrated, each of them has different options. Like for a cellular connection, you can, for example, use a regular modem, or you can also use the ZOBIM1. And yeah, so I mean, in any case, I think David really nicely demonstrated that with one or a combination of this communication method, you can really create the connectivity you need for your monitoring application, right? So David had one slide where you could see the ZOBIM1 was connected to an octohub, and the octohub again to a radio. So you can really benefit from the advantages of the ZOBIM1. At the same time, you can use an Ethernet connection, and you can even transfer data via radio in this combination, right? So it can be a combination of multiple communication methods, and even if the monitoring site is remote, very remote, where you don't have any infrastructure for communication, we can still get it to work. Of course, it requires some planning, but all is possible. And I really hope that this session provided you with some good overview about the different methods we have in place and we can use in combination with T4D. Okay, so I would like to provide you with an overview about our Trimble monitoring resources. So feel free to go to your browser and open monitoring.trimble.com. So this is our website, and on that website you can really find a lot of information, helpful information, an overview about all of our products, the solutions. You can read about different customer projects. There is also a link to different monitoring demo sites. So basically to Trimble 4D control, where you can also get an impression how the software looks like. And yeah, so of course you can also reach out to us via this webpage, our website. So I can just encourage you, maybe you want to have a look at the site. Apart from that, we also have a monitoring YouTube channel. If you open YouTube and you type in Trimble monitoring, you can subscribe for it. You will also be notified as soon as there is a new video. I think at the moment we have almost 50 videos available, videos that are short tutorial videos. One of them, coming back to your question, Zasulan, when it was about SMS notifications. So one of the videos, I'm not sure if it's already included. If not, that should be one we will work on shortly. So a 2 or 3 minute video basically that quickly shows you how you can configure an SMS gateway, or how you can make it happen that someone receives SMS notification from T4D. So this is just the idea of this YouTube channel, and there's really a lot of helpful information covered already now, and it's still growing. So we add more videos over time. There is also a monitoring community where we also share new news and latest releases and all kind of information in there. So that's also available. And now that we are the Trimble Geospatial webinars page, so this is a website that you can open. So there you can check for upcoming webinars, and you can also find the webinar recordings. And I think it's on the next slide. So it's geospatial.trimble.com. You will see it. You will see it on the next slide. So there you will find a lot of information about the webinars. And this one here will also be included. So you can also watch the recording afterwards if some communication scenario, for example, wasn't clear to you, so you can still watch it. And one good resource, and this is maybe still one of the best resources, is the Trimble distribution partner. As I just said or commented to Alexander's question regarding the cost per sensor and monitoring station. So I would strongly recommend that you reach out to your Trimble distribution partner if you are interested in a certain topic around Trimble monitoring. All right, so the next monitoring power hour, similar as today, with a different topic, of course, will take place on October 14th. And in this monitoring power hour session, Lee Helen from Monitum will share, let's say an industry professional perspective based on Monitum's journey with automated monitoring systems. So Monitoring is a company based out of Australia, and I'm sure Lee will give us a very nice overview and some insights on how they started and how they have used T4D to help elevate their professional service offering to what it is today. So I would be really happy if we can also welcome you to this session in October. All right. So now let me check if there is some more new questions coming in. No, I don't think so. I think we have already covered pretty much all of them. No, there is no new question. So if there are no questions, then I would like to thank everybody for your time and for joining this webinar. Thanks to David. Was very, very interesting. Thanks for sharing your expertise. And again, if you have any questions around any particular topic or specifically on communications, we are happy to assist and to answer your questions even after this webinar, of course. So just reach out. All right. So David, do you have any final comments? Anything you
I
might have
don't think
missed?
I have any specific comments. Thank you.
Okay, perfect. All right. So then, thank you again and talk to you next time. Bye-bye.